Good morning. So next section we see about the hydraulic circuit using control of hydraulic circuit using PLC. So electro hydraulic circuit connection with the help of PLC control. So we go for the actuation of two double acting cylinder. Okay. So like what we are seeing using the pneumatic circuit, there we are using a Versha Pro PLC software. With the help of that PLC, we are going to actuate the solenoid one, two solenoid. So one experiment we are having one solenoid, other experiment we are having two solenoids. In that we go for actuating the two double acting cylinder. So in some cycle of operation of A plus, B minus or A minus, any type of operation. Okay. Likewise here for hydraulic, we go for the another different software that we call as here totally integrated automation, TIA portal. So in that pneumatic, we are with the help of Versha Pro, we have drawn the ladder diagram. So here you are for Siemens totally integrated automation version 12. So TIA portal 12. So this is a home screen of the software. Okay. So you go for create new project, click. So name the project title, create. So automatically by default comes to the first step of the software integration. So software configuration. So there we are with the help of Versha Pro, we are drawn the PLC diagram. Then you go for configure with the PLC kit. Then we are uploaded to that PLC kit. Then you go for execution. But here in the case of TIA portal, so first you have to configure with the PLC device. Directly you are going to draw the PLC diagram. Okay. So here you go for configure device. So click configure device. So in that they show all device, add new device. I go for add new device. Click that add new device. So in that, so Siemens, so the kit they having the some number Siemens S71200. So that same number we are having in that software also Siemens. Okay. So here you are having the software. The same number Symantec S7120. Just enlarge that. I go for CPU. So in that the CPU number there they given 1214 DC. So same CPU number. Okay, enlarge your CPU. So in that first one, so that the first connection will be given to the PLC. I go for double click that. For configuring, I have to choose what type of PLC kit we are going to use. So there is a number of PLC. With the help of the single PC, we can able to control the number of PLCs. So that's the reason we are having the number of PLC and number of CPU here. So in that particular, chosen the particular CPU to connect with that. So it's take time to connect. So after that, this screen will be displayed. We are now trying to connect with that. So you go for making some IP. So through LAN only you are connected to the PLC kit with that software with the help of the LAN. So that I go for making some IP with that. So in that here the indication where you can just click it. So here bottom you are having the properties. So in that they show some Ethernet address. So here you are having that Ethernet address. So as per our PC IP, we will go for 192.168.100. Okay. So that's our IP of the system. So same can be given to connect with the PLC kit. So next go for online. So they asked which CPU you are selected. So same PLC kit CPU 1214 DC. That's the name of the CPU type. That they can be mentioned in the PLC kit itself. Next go for online. Next here they asked to select what type of PC interface. So here I go for the PN bar IE. So that's a interface here we are having. So they go for attempting to establish connection. So in this software, so online, that is a little bit difficult here. So with the help of that configuring the device, next you go for writing the program. So program part is easy. So configure software with that PLC, that's take much time. So we are making the attempting that connection with that our physical kit with the software. So they checking that connection. Okay, so this screen will be displayed here. So again I click go online. So they ask whether you are going to add the IP address to the same subnet of PLC. Yes. Click yes. So you have to wait. So they ask this thing. So change it. Yes, click. Okay, so once it get connected, we are able to get the orange color skin. So the skin will be changed into orange color. Previously it can be near somewhat this color. So once it can be connected with that PLC, so the color can be totally changed. Now so I go for the program black. So in that go for main OB. So enlarge that, double click the main OB. So this ladder will come. Okay, so now you go for drawing the ladder diagram. So here we are having the basic instruction, general bit logic instructions as well as the timer operation, counter operation. So now you go for drawing the bit logic operations. In that first I go for normally open coil, then normally closed, then output coil, then for latching that this can be connected here. So I go for drawing the ladder diagram for A plus B minus A minus. So I'm going to use two double acting cylinders. So for here we are latching. So this arrow can be just click it and drag it over the upper, so to able to get the latching. So for naming and all, there we are given so 1I, 2I, 1Q, 1O like that. So input output. So based upon that they having that. But this PLC here, so they mentioned that 0.1, 0.0 like that. So based upon that, so this is a PLC kit. So in that kit they having that around 13 inputs. We are able to get 10 outputs. So the name they given I1, I1, 2. So in that PLC kit they mentioned 0.0, 0.1, 0.2 like that. So we go for that same order. Okay. So in that they mentioned the 0.1, 0.2, 0.3 like that. So here also we go for mentioning this is your 0.0, 0.0, 0.1, 0.2, 0.3 like such we go for giving the inputs. Then in the case of output, this will be the 0.0, 0.1, 0.2. Okay. So output in the case of O 0.0, input in the case of I 0.0. So if I go for I 0.1. So this tag percentage of I 0.1 like that they came. Next I go for latching that. So Q 0.1. Then this will be the final latching. So I go for output as Q 0.1. Okay. So I go for draw the next ladder. So next one here I go for another. Next I go for the timer operation. So go for timer. So T on timer. So there the timer will be different. Here we are the timer will be different. Okay. Go for automatic. Click OK. So this will produce an output. So give the output here. Okay. So again here give Q 0.1. So output will be the M 0.1. Okay, same M can be here. I go for disconnect the or break the previous circuit M 0.1. So I go for another rung. So normally open. Okay, so I go for normally closed, then latching, output. So this will be the M 0.1, so Q 0.2, so this also Q 0.2. So next I go for another timer. So here I go for 2 cylinder, so I go for 4 timer. So first I go for bit logic operation, normally open coil I placed over here. Next I go for T-on timer, click OK. So this will produce one output, so here I placed here. Okay, so this will be the Q 0.2, so this will produce an output that we call as M 0.2. So same can be used for breaking the previous circuit, M 0.2. Okay, so next go for third output. So normally open coil, next normally closed coil, next latching of normally open, this can be latched, next output coil, so this can be named as M 0.2, so output is Q 0.3, then same can be latched, Q 0.3. okay, so again go for another timer. So normally open coil, go for T-on timer, click OK. So this will produce an output, so Q 0.3 as input. Here I go for M 0.4. sorry, M 0.3. M 0.3. So same can be used for to break the previous circuit, M 0.3. Next I go for the fourth output. So normally open coil here, then normally closed, then again latching, then I go for an output. So this is the Q4. So M 0.3 will produce an output as Q 0.4, final output. So that can be latched here, Q 0.4. Then after that, the next timer. So though it's a continuous cycle of operation, so you go for starting once again the first experiment, in the case of first run. So that's the reason I go for the latching the last timer to the first run. Okay, so this will produce an output that we call as M4. So Q4 0.4, here produce M 0.4. Then here I go M 0.4 for to break the previous circuit. Likewise I go for latching the first circuit. So cycle of continuous reciprocation, I go for latching the final output timer to the here to start the next cycle. So this is a ladder program for A plus B minus A minus. So there the timer we are go for latching the preset time, but here we directly give the time second in the multiples of 1000. So defaultly in the case of there we are having the 10th, 1000 and 100, that type of timers. So when you go for the registers, in that registers we are assigning some values in the case of VersaPro software. So in that totally can be changed. It's automatic timer, they directly enter the times. In the case of 1000 can be taken as a millisecond. When you go for the eternal time, only you go for the preset time only for this operation. So just click that. Here I go for 2000. So this will be the 3000. Here will be again 2000. This can be changed into 3000. Okay, so this way I assign the time values. Okay, So after that we go for load the program. So this is a program for 2 double acting cylinder continuous reciprocation. Okay, so I going to load the program. So download to a device. So click download to a device. The program which you are drawn through this TIA portal, that can be download to the PLC kit. Okay, so it will take time. So this can be already, it can be connected. It can be going to compile and take. So here they ask to make the accept all the different configured models, different models that can be accept. So make it click accept all. Okay, load. So they ask start after downloading the models. Yeah, start all. Click enable, check the start all. Click finish. So once you enlarge or it can be downloaded, so this stop button will get now enabled. So the thing, all the things can be converted into green color. Previously it can be in a red or orange color. Now it can be turned into a green color. That's the stop button also now it get enabled. Okay, now the program can be downloaded to the device. Next come to the PLC. In PLC it shows green color. Previously it was orange color. Okay, so that indicates it's in a process. Now the program can be downloaded to the kit. Okay, so this connection I'm going to make. So I given input as I1. Okay, so that this will be the I1. So this I0. So this will be I1. I take an output in the case of Q 0.1, 0.2, 0.3. Parallel go for giving the connection. Okay. So now I go for simulation with the help of this LED. So I didn't connect the two double acting cylinders. That means solenoid valve. I didn't connect the solenoid valve. Just I go for actuating with the help of the board itself. So still there is no any input supply I can given. If I press that I1, so if I go for another see that I1, then go for off. So we will able to get the output here. So parallelly we are able to get the output in the case of 2 seconds. So 2 second time delay. I able to get the output in the 1, 2, 3, 4. That means 0.01, 0.02, 0.03, 0.04. So this output can be connected to the hydraulic trainer kit. So this is electronic hydraulic kit. Previously we are seeing the basic hydraulic trainer kit. So same connection. So from the tank to the tank distributor. So this we call tank distributor. So from that you are given to the 4x3 solenoid valve operated DCV. So these two can be 4x3 solenoid operated DCV. So these two can be given to the output. So these two, this can be drain port, and these two things can be given to the output of the double acting cylinder. So these two will be given to the double acting cylinder. So one is taken as a power source. This can be given drain. Likewise, these two can be given to the another double acting cylinder. Here have so two double acting cylinders. So this can be used for extension retraction. So this is one double acting cylinder. So this is another double acting cylinder. We go for rotary type. So instead of the linear one, we go for rotary type. That means clockwise, anti-clockwise rotation. So that can be considered a rotary actuator. So this will be the linear actuator. This will be the rotary actuator. So we can take it as one of the double acting cylinder. So in the case of clockwise direction, that will be the extension. Anti-clockwise direction, that will be the retraction. So that way you can give the connection to the two double acting cylinder. So now I go for connecting the linear actuator. So double acting cylinder, linear actuator. So give the connection of A plus and A minus. I taken the same output from the PLC. So one can be given here. Then other can be given to the output of Q2. Okay. So apparently we are able to get the solenoid energizing and de-energizing. Okay. So I go for the switch on the pump. So now I am able to get the extension, then retraction. Okay, so extension and retraction. Now I go So now I go for giving the connection of another double acting cylinder, that is rotary double acting cylinder. I go for the A plus, so this will be the A plus. Next A minus. Okay, so now we connected the two double acting cylinders. Okay, in case of rotary actuation, so only with the clockwise, so in case of anti-clockwise. Okay, so extension clockwise, retraction anti-clockwise. So A plus B plus, then solenoid. So consider rotary actuator is nothing but A cylinder, A plus A minus. So in the case of double acting cylinder, we go for B plus B minus as a linear actuator. If you want to change any sequence, so just to change the connections in the case of PLC panel board itself. So if you change the connection of positive negative, you are able to get the actuation based upon the sequence of A plus B minus. Okay, but the PLC can produce 4 output constantly for each time delay. Okay, if you want to see that, if you go for pressing Alt T, so now you are able to see that flow diagram. So if I press a Control T, so that means the ladder, how the flow or the timer running, all those things can be, you are able to see that. So that blue color indicates a flow of current, then comes again once again back. So here through this you can able to get connection. Next like that. So that blue color indicates a flow of signals from one rail to the other rail. Okay, so this is a working operation of A plus A minus B plus B minus using hydro-pneumatic trainer, electro-hydraulic trainer kit. Okay.